Hi class, welcome back for lesson 2. We're going to be talking about graphing linear relationships. So in lesson 1, the relationships we invested in graphed were discrete relations because they were given a domain with finite numbers. Finite numbers just means that there was a certain set of numbers and they couldn't be any other number but that. When you're looking at a domain for a continuous relationship, we write it as D is equal to squiggly bracket X line X E R squiggly bracket. What this is basically saying is, this means, in English, the domain is X such that, and that's what that top part represents, such that X is an element of all real numbers. Right? So it means that X or X values are any real number. That's what this R represents. It just means real numbers. E actually means element. And this line actually means such that. Okay? So what is a real number? A real number is any number, an integer, a rational number, so a fraction, an irrational number, any of those, right? So it's a real number. We'll talk about invisible numbers when we get to grade 11, so don't worry about them for now. Don't worry about them for now, but a real number is anything that is irrational number, anything that cannot be made by dividing two integers. Okay? What does this mean when we're graphing this relationship, right? It just basically means that we can choose a few x and determine their y values. And remember, these are just a few parts of that graph, or parts of that relationship. The reality is this can be made up of an infinite number of points, and we can graph our ordered pairs from the table of values and then connect those points together with either a line or a curve that has arrows indicating that this line or curve can go on forever and ever and ever and ever. When we connect these points with a line, we're basically indicating that x can be anything on this line. So any small little dot on this line can represent x. So our focus in this lesson and in grade 9 is going to be something that we call linear relationships, right? So a linear relationship is basically a relationship in which one variable, so something like y or x or c, right, is going to equal some sort of x value, but only with one exponent value on it, if that makes sense. So a linear relationship is basically something that's going to give us some sort of a straight line. So I'm just going to go write that in. A linear relationship is a relationship or a relation in which the graph forms a straight line, which makes sense because it's linear, and linear just means line. Okay? All right. So moving on. So a linear relationship could look like this. I'm going to draw it in a nicer pen. Could look like this. You're going to want to draw this with not the way I'm drawing it. You're going to want to use a ruler, but I don't have access to one of those, so I'm just using it like this. Your linear relationship could also look like this, right? It just really depends. Okay. Alrighty. So we're just going to move on, and we're going to say, for a relationship, y is equal to 3x plus 1 with domain -2, -1, 0, 1, 2, construct a table of values. In this situation, right, this is a discrete function. And the reason that is because we're given very specific coordinates that we can have. So I'm going to put in those coordinates here. We do -2, -1, 0, 1, and 2. And in order to find the y, I'm just going to plug it into the equation. So y equals 3 times negative 2 plus 1. You don't always have to write this in. I'm just doing it for the purposes of showing you how I found each y plus 1. So it's going to give me negative 5. And I'm literally just plugging them into my calculator. Right? I'm going to do the same thing here. So I'm going to do y equals 3. And again, you really don't have to do this. I'm just doing it to show you. Plus 1. Negative 3 plus 1 is equal to negative 2. Then I'm going to do y equals 3 times 0 plus 1, which is going to be 1. Then I'm going to do y is equal to 3 times 1 plus 1, which is going to be 4. And then y is equal to 3 times 2, which is 6, plus 1 is going to be 7. And I'm just going to go plug these in. I'm going to do negative 2 is right here, and I'm going to go all the way down to negative 5. Then I'm going to do negative 1, which is right here, and I'm going to go all the way down to negative 2. Then 0 is going to be at 1, and then 1 is going to be up at 4, and then 2 is going to be all the way up at 7, and I'm just going to draw in a line here. I actually didn't realize that I have this function, so I'm just going to draw it from here. Oops. I'm just going to go in and draw that in. So, never mind, I don't have that function, ignore me. So I'm just going to go draw it in. So I'm going to say it's coming from here. So I'm just going to connect these dots together. So I'm going to go do this. And please use a ruler. Don't look at me for an example right now. I don't know how to use a ruler on this thing just yet. All right. And that is what my relationship would look like. Ignore that. You actually shouldn't be drawing a line through it because it's a discrete function. So we're leaving it. I struggled with that for no reason. Right? So here it says graph the relation y equals 2x plus 3. So we want to graph it in two different ways. So I'm going to do the first one like this, where I'm given this domain. And I'm going to do it in green. So I'm going to say x is equal to negative 2, negative 1, 0, 1, 2. Okay, if that's my domain, I need to make sure it's a discrete function. So I'm going to say y is equal to 2, negative 2 times negative 2 plus 3, right? So that's negative 2 times negative 2 is positive 4 plus 3 is going to give me 7. And I'm just going to do it for all of them. So I'm not going to show you how to do it because we've already gone over this. I'm just going to plug the negative 1 in, and that's going to give me 5. Negative 2 times 0 is just 0 plus 3, right? Negative 2 times 1 is going to give me negative 2 plus 3 is going to give me 1. And then I'm going to do negative 2 times 2 is going to give me negative 4 plus 3 is going to give me negative 1. Okay, now that I have my points, I'm going to go in here and I'm going to say, okay, I have negative 2. I'm going to go all the way up to 7. I have negative 1. I'm going to go to 5. I have 0. I'm going to go to 3. I have 1. I'm going to go to 1. And I have 2. I'm going to go to negative 1. That is my discrete function. That's it. That's what it's going to look like, right? But when I'm given something like this, the real numbers, that's where this starts to change. That's where I can draw this line here. I can connect these two together, right? Because now I'm saying all of these count in that function. So this line represents B, but these individual dots, and I'm just going to do this like that, represents A. Okay? So it says graph the relation y is equal to 2 over 3x minus 1. I'm not given a domain here, so I'm going to assume that. So for these ones, I usually just pick, because it's 2 over 3, like normally I would just pick 1, 2, 3, 4, 5, 6, or like negative 1, negative 2, negative 3. But because it's 2 over 3, I honestly dislike working with fractions so much. So I'm going to change this into a way that I don't have those fractions. So I'm going to go with negative 6, negative 3, 0, and positive 3, positive 6. Right, just to get rid of those fractions. So y is equal to 2 over 3 times negative 6 minus 1. Right, this becomes 2 times 2. So 4 minus 1. Right, or negative 4 minus 1 because it's negative 2. So negative 4 minus 1 is going to give me negative 5. So I'm going to put that in here. Then I'm going to do negative 3. So I'm going to do y equals 2 over 3 multiplied by negative 3 minus 1. Negative 3 is going to be left with negative 1. So negative 2 times negative 1 is just negative 2. Minus 1 is going to give me negative 3. Right? And again, I'm using these numbers just because they're easy to work with, and I don't want to be plotting decimals. Just annoying. So then I'm going to do 2 over 3. 0 is always a great number to work with. Right? 2 over 3 times 0 is just 0. Minus 1 is just going to give me negative 1. And I'm going to do the same thing for the positive values. I always like to have one under. I like to have negative values and positive values, and I like to have 50-50 of each. So 0 usually falls in the middle for me. So y is equal to 2 over 3 times 3 minus 1. This is going to be 1, so it's going to be 2 minus 1 equals. And then last but not least, I'm left with y is equal to 6 times 2 over 3. So 2 over 3 times 6 minus 1. The 6 and the 3 cancel each other out. I'm left with 2. 2 times 2 is 4 minus 1. This will give me 3. Right, and do you see how like those numbers are just easy to work with? Otherwise we would have been left with decimals, and that wouldn't have been fun to work with. So I'm going to go to negative 6. I'm going to go all the way down to negative 5, and I'm going to put that dot there. Then I'm going to go over to negative 3. I'm going to go all the way down to negative 3 here and put that dot there. I'm going to go to 0, and it's going to be at negative 1. Then I'm going to go to 3, and it's going to be at positive 1. And then last but not least, I have 6, and it's going to be at positive 3. Notice how I picked those numbers. They were just random numbers that I picked. And it says graph the relation. It doesn't say anything about it having a discrete set of numbers, nothing about it having a certain set of x values. I picked the x values myself. So this means that this is a continuous function. So I'm going to go in, without my ruler, of course, and just draw it in. So you are going to use a ruler and be better than I am. And I was really hoping that it would fix itself, but it didn't. Okay. And you want to connect all the dots. Because of the way that I drew this in, it didn't connect all the dots, but you get what I'm saying. Right? And that is my relation. Let's do the same thing for lesson example 4. We can write the equation using this. So I'll show you how to draw the equation using those graphs. Right? And yeah. So I want you to try example 4 on your own. And then when you are done, unpause this video, right? And just come back and watch how we do it. It's a little bit more complicated. You're going to have to rearrange the formula to get y by itself. Okay? Alrighty. So hopefully you have paused this video, you're coming back to watch it to find the solution, and you've tried it by yourself. So first things first, you will need to get this y by itself. Right? So let's do that. So I have x plus 4y equals 8. We kind of already did this last unit, right? I want to move this x, I want to get rid of it, so I'm going to do x minus x plus 4y equals 8 minus x, right? X minus x, get rid of each other, so I have 4, y equals 8 minus x, right? And I want to get rid of this 4, so I'm going to divide by 4. I'm going to divide this entire side by 4. So I'm going to be left with y is equal to 8 over 4 minus x over 4. 8 over 4 I can actually reduce to 2 minus x over 4. Right? So I'm going to take this new equation and I'm going to start plugging in my numbers. So let's go here. So I have y is equal to 2 minus x divided by 4. So again, I'm going to want to work with numbers that I like working with. So I'm going to personally make x negative 8, negative 4, 0, 4, 8. Again, because I really hate working with fractions. So I'm going to say y is equal to 2 minus negative 8. And I'm going to make sure I put that in brackets, divided by 4. First things first, I'm going to do division. Negative 8 divided by negative 4 is going to give me negative 2. Two negatives together will give me a positive. That'll give me 4. And again, you can just punch this into your calculator if you would like. Y equals 2 minus negative 4 over 4. Again, 2 minus, and that minus stays there because I'm not changing it. The negative is still there. Negative 4 over 4 becomes negative 1. 2 negatives equal a positive, so this becomes 2 plus 1 equals 3. Okay? Oops. Then I'm going to move on. Y equals 2 minus 0 over 4. 0 over 4 is just 0, so I'm left with 2. 2. This is 3. This is 2. All right. And then I'm going to do y is equal to 2 minus 4. I'm going to make sure that's in brackets, over 4. 2 minus 4 over 4 is just 1. 2 minus 1 will give me 3. Sorry. 2 minus 1 won't give me 3. 2 minus 1 will give me 1. Sorry. 2 minus 3 will give me 1. And then I'm left with y equals 2 minus 8 over 2. 8 divided by 2 is just 4. 2 minus 4. Oh guys, sorry, I made a mistake. Y equals 2 minus 4 over 4, which will give me 2 minus 1 equals 1. And this is why when we're doing math, we are not concentrating on other things like I was. 2 minus 8 over 4, and make sure that 8 stays in brackets. 2, 8 minus 4 is, 8 divided by 4 is just 2. 2 minus 2 is 0. Alright, so that's my answers right there. So 4, 3, 2, 1, 0. I'm just going to go plot. So do I go to negative 8? Yeah, I do. And I'm just going to go down or up to positive 4. Negative 4, up to positive 3. 0 is going to go to positive 2. Positive 2. 4 is going to go to positive 1. And then 8 is just going to be at 0. So it'll look something like that. And again, this was a linear relation. And because we picked those numbers by ourselves, we're just going to draw in our line, and yours is going to be straighter than mine, and that's the answer. Okay, so that's how I did mine. You might have different plots on this graph, and that's fine, as long as it looks something like this. So it says use the points in the graph to write the equation to describe each relationship, right? So how you're going to do this is, first things first, I'm going to make this x, and I'm going to make this y. And I'm just going to give myself some x and y points. So I'm going to say this point is x is negative 4. Sorry, x here is negative 4. And the y is also negative 4. So this is negative 4, negative 4. We're going to go here. Negative 3, negative 2. And here we have negative 2, 0. Here we have negative 1, 2. And then here we have 4, 0, and 4. So those are my coordinated pairs. So I'm just going to go put those in. So I have -4, -3, -2, 1, and 0. On the other hand, I have -4, 2, 0, 2, 4. So it says, use the points on the graph to write each equation to describe each relationship. So how are these actually changing? So look here, right? We seem to be going up by 1, 2, and over 1. We're going up by 1, 2, 1, 2, and over 1. 1, 2, and over 1, right? So I'm saying that maybe it is -4, right, times 2, right? So -4, I'm going up by 2 over 1. So it might be -4 times 2 minus 2. Let's see if that works. Because that's where I seem to be intersecting, or 4, +4, because that seems where I'm intersecting with that y-axis. So my 0 seems to be at 4, right? So it has to be +4, and then I'm seem to be going up 2 and over 1, which means that maybe I'm multiplying by 2. So let's try if that works. So let's do 2 times -4 plus 4. Let's see if that works. 2 times -4 is going to be -8 plus 4 will give me -4. It worked for that one. Okay, so let's see if it works for the next one. Let's see if it works for -3 times 2 plus 4. -3 times 2 plus 4. Yep, that makes sense. Right? -3 is at -2, so that makes sense. And let's try with 2 times 1 plus 4. Or sorry. Because now I'm at, where am I? This is -1, don't forget that. So if I did -1 times 4 plus 4, seems to work, right? And they all seem to work. They all seem to work, okay? So I could say that if I multiply 4 by, or sorry, if I multiply 2 by x, and then I add 4, I get y. So that would be my relationship. Okay? So this +4 will become important. So the +4 is where the 0 intersect, where the x is equal to 0, right? We'll always go there. And then you're kind of going, I'm going up 2 and over 1. So 2 over 1. And I'll explain why this becomes important when we talk about slope. Okay? So let's try using that same logic with this equation as well. So I always like to go in and write my points, right? So I'm just going to make an x and the y. All right, so I have my x, I have my y. So my first one is going to be over here. My x is -5 and my y is 4. So -5, 4. -3 and 3. -3 and 3. Then I have -1 and 2. -1, 2. I don't have a 0, unfortunately. Like my 0 is kind of like 1.5 maybe, but I don't really know what it is. So I'm not going to go there. So I have 1 and 1. So I have 1 and 1. And then I have 3 and 0. 3 and 0. And then last but not least, I have this 5 and this -1 here. 5, -1. Alright, so I have my coordinated pairs in. And I'm going to go back and look at this. Now, remember how here we went up 2 and over 1? Let's see what we're doing here. We're going down 1 and over 2. So when I wrote up 2 over 1, I wrote it as that. If I'm going to go down 1, -1, and over 2, I can write that as -1 over 2. Right? So I can say -1 over 2 times x plus some number is going to give me y. And I want to find that some number. Do I have an x and a y that I can plug in here? Yeah, I do. I can say negative 1 over 2. Let's just work with the one that I have, negative 5. Plus, we'll make this b is equal to y, which is just 4. Now I can find what that b is. Negative 1 over 2 times negative 5. So that's just going to become negative 1 times negative 5 is just 5. So it's going to become 5 over 2 plus b is equal to 4. Right? Now I want to get rid of this 5 over 2 on this side, so I'm going to use 5 over 2 minus 5 over 2. Again, if you want to turn this into a decimal in this unit, be my guest. I'm just doing it as a fraction to show you how to do it. Right? So b is equal to 4 minus 5 over 2, so I got to change that 4 into 8 over 2, which is just an equivalent fraction. And I'm going to write this in a different color over here so that you can see what I did. Right, so I did 4 over 1 equals times 2 times 2, 2, 8. I just took that there. Minus 5 over 2. 8 minus 5 is going to give me 3 over 2, b. Right? So, let's see if this works. What if I did negative 1 over 2 x plus 3 over 2 equals y? Does it work for all of them? I'm going to make this in a way that it is decimals. So what if I did negative 0.5 times x times 3 over 2 is just 1.5 equals y. So I did that with negative 5. Let's try it with negative 3. So let's do negative 0.5 times negative 3, and I'm just plugging it into my calculator, plus 1.5 will give me 3. So it worked. Let's try it again with negative 0.5 times negative 1 plus 1.5, 2. And if I go on, so on and so forth, it always works out for me. So I know that my equation is going to be this right here. Okay? And we'll talk more about why we did the moving down 1 and over 2, but tomorrow when we talk about slope. But that is a way for me to figure out the equation without having to go through the whole process of guess and check. All right? So that is that. Your homework is posted on D2L. It is a worksheet for you to try doing. So on top of, so these are two, this is for lesson 2. For lesson 1, you have your the stuff from that lesson as well. And then this is the stuff from lesson 2. All right, see you tomorrow.